Please welcome Dr. Chris Lewis, who is a researcher and practitioner at Newcastle upon Tyne Hospital in Northern England. An article he authored was recently featured in the journal Burns and reviewed a pivotal clinical trial for the DeepView wound imaging device. Chris, one of the highlights of your paper was the 95% accuracy that was reached in the study. How important is this result to the burn community?
I really hope that the results that we've independently assessed, presented and published in Burns should provide reassurance to colleagues around the world that this is a viable and exciting technology and really represents the cutting edge of burn care and depth assessment. The reason I got involved in this evaluation study is that depth assessment interpretation has not really changed very much in the last 20 years. Technologies remain the same. There's been no specific refinements in the hardware to adapt it to the changing and dynamic needs of the NHS or global healthcare. Sites no longer have room for heavy, large pieces of kit. We need portable, efficient and user-friendly devices that are encompassing new and current technology. And with further iterations of the device and software, there's going to be even more applications to support us in our decision-making in burn care. I think it's a really exciting time to be involved in this project and generally in burn care.
That brings me to the question of how the trial was designed, how many patients were there, and how did it measure efficacy? What can you tell us about these aspects of the study?
So we collaborated with another UK site to form a multi-centre device evaluation, and we've looked at all of our adult patients with thermal burns who've been managed non-operatively, excluding burns to the hands, feet and face, and then reassessed them at 3 weeks to see whether their wounds had healed or not. So that's really key, because there's a wealth of data to support complete wound healing by surgery or dressing management within 3 weeks to achieve a better scar quality. And by looking at the photos of the wounds at 3 weeks and plotting out the unhealed proportion, we first generated our ground truthing data. We could then map out the predicted non-healing areas on the DeepView scan that it had given us from the original data and compare the two, giving us accuracy data.
Okay. And, beyond the headline 95% accuracy number, there are also some other performance statistics that were provided. What are some of the other of these that were out there, and what's their importance?
That's right. We looked at a range of other things. We looked at positive predictive value. So in other words, the likelihood that a wound identified by the multispectral system as healing within 3 weeks actually did. We also looked at negative predictive value. So the likelihood that a wound predicted to take longer than 21 days to heal did take that time. So our positive predictive value to identify wounds healing within the 21 days was 90%, and the negative predictive value was 93%. And combined, we felt that these results indicated reliable identification of wounds healing within the metric timeframes that Spectral gave us.
Okay. And as I understand it, the DeepView device provides a binary output, I think, whether or not a wound is going to heal in 21 days, but it actually takes in a lot of information that could potentially be helpful for treatment of a burn. Could providers benefit from a range of values from the DeepView device?
I think you'll get different answers from different people and different surgeons and different specialities. So the traditional technology that we used would provide a heat map output, which guided us on which areas are going to heal within 2 weeks, 2 to 3 weeks, and beyond 3 weeks. And while that's an advantage, it does require a higher level of interpretation, which is more in my realm as a burn surgeon. So I think there's two advantages to the binary output. So for non-burn staff who might be evaluating wounds in remote sites, general hospitals, or even in the military on the field, a binary output provides a clear and quick answer that this patient will benefit from the expertise of a burn service and that an appropriate referral should be made. A heat map in that scenario is going to be unhelpful and subject to interpretation. I think the second benefit I find is that the output can be shown to patients who are then able to appreciate which parts of their wound need surgery. It provides a clear, user-friendly image which can help support their decision making. And we're currently doing another piece of work looking at exactly that, how the output can support our patients in consenting for their surgery.